Welcome to Control Structure Lecture 3. So, Lecture 5 to be precise. So, we will have a new task. So, the task is we should generate the first n prime numbers. Okay. So, we can have some assumptions. One is not a prime number. Then 2, 3, 5, 7 are prime numbers. So we will accept our value of m to be greater than 4. Okay. A prime number, a prime factor of any number is the range of numbers from 2 to square root of that number. If number n is not exactly divisible by its prime factors, then n is a prime number. So these are certain tasks that we have. So let me break down into apply problem solving and try and break this into the logic. So what does it say? The first I need to accept a value which is greater than 4, and then from 5 onwards I should check whether each number is a prime number, which means that 2, 3, 5, 7 is already a prime number. So we have to start from 9, and we also know that all even numbers except 2 are not prime numbers. So these are certain assumptions. So we will hash include this. We'll now have a counter which will count from 9, because we want to check the numbers from 9. We will also have the number, or we can also have prime count, which I initialize to, in this case, 4. Okay. Then subsequently we will see each one of them is the way each variables when we try and write the program. So first let me enter the value of n. Printf input n. So scanf %d and of n. So this is our n. So we need n here. So what we will do is the first n prime numbers are, so we'll give n, okay, which is first we will print 2, 3, 5 and 7. Then we have the remaining to be printed. So here we will please enter the value of n greater than 4. Okay, so prime dot c will store it in e. Okay, so I have input n greater than 2, 3, 5, 7. Now while my prime count remains less than n, I need to find out whether from prime count to n, how many n prime numbers exist, or how many n prime numbers actually I need. So I should, if the prime count, if the value of n is 10, my PC, as long as my PC is less than 10, keeps on finding the prime numbers. So first things first, first thing what we have to do is we take the number which is our number, that will assign it to temp. So that is our counter, in this case 9. Now what we will do, we will say all numbers are prime number, just put a flag, we will say p flag, this will be equal to 1. So I need to first find out the prime factors. To find out the prime factors, I need to find the range. So my range of a prime factor is nothing but square root of the counter, integer value of the square root of the counter. So I will also have one variable called range. This is my prime factor range. That include math.h, because I am using square root. Okay, so we'll do this program slow, step by step. First let us print the prime factors, if at all there are any prime factors. So for, say for example, I'll say int I, for I is equal to 2 to I less than or equal to range I plus plus. So printf slash n, the prime factors of, this is only to check the output intermediately, percentage d r, which is nothing but our counter. We look at the prime factors, we'll print it, print percentage d I. So these are our prime factors. Okay, so first we are printing the prime factors just to see whether we are getting proper prime factors. So my counter is less than or counter is equal to counter plus 1 for the next number. Okay, so now let me save this and get the prime factors. GCC prime dot minus o op prime dot c. Okay, lucky. So I'll give 5. Now this is looping because we have not given, right? So we have to print the prime factors. Let us look at the code. Since I have given PC, right, less than n, so I'll make this as counter so that it is easy for us. So the prime factors of the counter are, we're just looking at the prime factors, please. Okay, so in this our counter is 9, so we'll give something that is, we will say 10, just to get the prime factors. Right? So so I'll give say 12. Okay, so the prime factors are of 9 are okay, 10 are 4. So we have a, from here the prime factors of 9 are, it is looping twice, so we will take this fellow out and put it here to get a proper output. Save, just to see whether we are getting proper prime factors. So I'll give 10. So the prime factors of 9 are 2 and 3. That is because why it is giving 23, because I am not displaying it properly, comma. Okay, so now I think it's fine. Okay, so I'll give 10. So the prime factors of 9 are okay, and I'm getting 20. I did not save, sorry. So I'll give 10. The prime factors are 2 and 3. All right. So if I now look at the prime factors of say 25, okay, so up to 25, see the prime factor for 10 are 2 and 3, 16 are 2, 3 and 4. So if any number is not divisible by these prime factors, then that is a prime number. For example, let us take out odd numbers. So these are not prime numbers. Okay, so then what we will do is, since odd numbers, even numbers are not prime numbers, we'll make the display better. So for that, I instead of making for 2, I'll make it from 3, so that there is no point in, because we know the number will be even numbers are divisible, right? So we will look at this, and we will also now we'll loop from counter. Will not make it counter plus 1, we'll make counter plus 2. So we'll only look at odd numbers, right? So I hope you are getting the logic slowly. If you don't get, rewind and check it. So let me give 20. So the prime factors of 9 are 3, 11 also 3, 13 also 3, 15 also 3, 17 is 3 and 4, 19 is 3 and 4. Which means if 9 is divided by 3, it's not a prime number. 11 is divided by 3, then it's not a prime. In this case, 11 is not divided by 3, which is a prime number. 13 is not divided by 3, it's a prime number. 15 is divided by 3, so it's not a prime number. 17 is neither divisible by 3, not divisible by 4. 19 is neither divisible by 4, neither divisible. So which we have a logic there, right? So what I will do for that is, so now we know now we understand the prime factors, right? So here what we will do is, we will try and in the loop, I have a loop here. Okay. In this loop, what we will do is, we will take this value, which is our counter. If my counter mod I is equal to 0, means prime factor is able to divide the counter. The moment I get that, right, first thing I'll make is, I will make this flag, means that number is not a prime number. Okay, I'll say p flag is equal to 0, and I'll break this loop. There is no need, if it is divisible by 3, even one of the numbers, I don't want to loop it further, just to make it efficient, right? Here what I will do is, I will put if it loops here, and if my p flag remains 1, which means that the prime factors did not divide the number, means it is a prime number. So if p flag is equal to 1, or I can as well say if p flag, then I will print that counter. That's a prime number. Okay, %d space, this is my prime number anyway. Okay, and then I will increment the counter, because we have to print the first prime number. This is the one prime count is already happened. Okay, so whatever is the status of my p flag, because it would have become 0, it would have remain 1, I'll again my p flag I'll make it as 1, because hoping that the next prime number next is also a prime number, right? If it is not, the p flag will be 0. So I will make this my nc less than n. Okay, so now let us see, this program works fine. Okay, undeclared nc. All right, so I will have a variable called, okay, that is not nc, that is our pc, which is my prime count. I'll say pc, then maybe I'll say pc here. So in this case, now my pc should remain less than n, not the counter. Okay, so that this is fine. Alright, so I'll give 5, so it gives me 2, 3, 5, 7, 11, isn't it? So now if I say please generate say 100 prime numbers, it generates 100 prime numbers. If you verify, all these are prime numbers, nothing is divisible by its prime factor. So we have a logic working here. One of the observations that you see, I have given a break here, which means if it is not a prime number, let us print that just to see which are not prime numbers, which. So our counter percentage %d is divisible by okay, so let us now look at this. So let's suppose I want to generate 5 numbers. Okay, so if you see 9 is divisible by 3, and this is the next prime number. Okay, that's what the display actually says. Okay, so let me compile it. 5. Okay, see 9 is divisible by 3, that's why it's not a prime number, right? So it is 2, 3, 5, 7, 11. So suppose if I give say 10, for example, first 10 prime numbers. Now 9 is divisible by 3, 15 is divisible by 3, 21 is divisible by 3, 25 is divisible by 3, 27 is divisible by 3, which means these are all the prime numbers. Correct? Which one? The 11, 13 is a prime number because that is not divisible by 3, 17, 19, etc., etc., isn't it? So this in a nutshell, right, is a lecture on okay, if you again look at the value of I, for example, 15 is divisible by 3 and it stops there, correct? Because there is no point in me continuing, and that is the role of break. Okay, by default it continues. Okay, if I don't do this, it continues. Otherwise it breaks, and then once it breaks, it will come here and then it will go back and then to the while loop. Now for example, suppose if I after this, if I just put a break, for example, I'm outside the for loop now, and try and when I compile this and when I do the OP and when I say 5, right, so it just stopped 2, 3, 5, 7, and then it checked for the P flag. Before the P flag, I am coming out of the while loop, isn't it? Instead, if I just say continue, right, so when I do this continue, so I give 5. Even now it is, right, it is just continuing. If there is an infinite loop, if you just see, it will come till here and continues to the loop. So it doesn't come here at all. Now if I just take this and after I do the P flag and I just put the continue here, for example, okay, that looks to be a normal continue, isn't it? So now if I break here, for example, let me just give say 10 prime numbers. Okay, so that's a normal continue. So it just continues by default. Now if you put a continue somewhere here, it will continue from there, means it will come till here again continue, so it will never come reach down. Now suppose if I do just a break here, if I just do a break here, that's the last statement of my code, and I do the GCC. Now if I say 50 prime numbers, it just ends at 2, 3, 5, 7. That is because, right, it comes here, right, and breaks. Which one it will break? It will break the loop. Now why did, you may ask me, why did it did not print 11? Because it took 9. Since 9 is not a prime number, so it did not print the prime number, and it incremented the counter to 11. It made the P flag 1, and you break. So break means you directly came outside the loop, isn't it? So this is just an application of something called break and continue. Okay, the rest in the subsequent lecture. Thank you very much.